we're going to do our video here on Extrema on an interval, which is really just the beginning of you starting to learn the importance of these derivatives and how to actually use them on graphs. So let's get to it. So Extrema, by the way, definition of Extrema is really it's just like a maximum or a minimum. Like if there's a graph, there's a little bit of a hill, that's Extrema, the top of that hill. If there's a little valley, the bottom of that valley is also Extrema. Okay. Sometimes the Extrema is an absolute maximum. Sometimes it's an absolute minimum, and we'll get to that more in here. Definition of relative Extrema is really when something is increasing on the one side and then is decreasing on the other side, and then that tangent right there, that'll be in Extrema. Okay, so the definition of all this stuff is right here. So it's really just like it's actually probably easiest to look at this little graph right here to explain some of this stuff, and then I'll go ahead and start talking about critical points and whatnot. So just looking at this graph right here, so an absolute maximum is going to be the highest point. It's not necessarily the top of the hill, but it's just the highest point. So the absolute maximum on this graph right here is going to be the tallest point right there, which is 4, 21. And this is the point, 4, 21. The absolute minimum is the lowest point, which is right here, which is going to be -2, -15. Relative, and this is where it gets maybe a little confusing, but you'll figure it out. Relative maximum, that's when we have like a hill. So right here is a little hill. So if you notice, it's increasing, then it's decreasing. So increasing, then decreasing. That's going to be your relative maximum, and that's going to be at the point 0.5. Now, is it possible for the relative maximum to be the absolute maximum? Yes, it happens quite frequently. But on this problem, it does not. Relative minimum, that's going to go from decreasing to increasing, so that's going to be right here. So at 2, 1. All right, and then usually we're not going to be given a graph with this stuff. And you just need to find critical points. So critical points are the interior point of the domain of a function where f prime is 0 or undefined, and that's a critical point. And there's two types of critical points. There's something called a stationary point, and that's when f prime equals 0 at that point, or there is a singular point, and that's when f prime is undefined. Okay? And relative extrema can only occur at critical points. So let's start to actually go through this. So today we're going to be working really just on extreme values, not relative values. So the extreme value theorem is saying that if f is continuous on an interval, then it contains both an absolute maximum and an absolute minimum. So what we're going to do now is the candidates test. So again, if it's continuous, we're good to go on all of these. And these examples will be continuous here. So the candidates test, super important test. It's asked to find maximums and minimums. Okay, so if you ever see the word absolute maximum, it's the same thing as just maximum, because sometimes a problem will just say, what's the maximum? So you have to, so if it doesn't say absolute, it means it is absolute. Same thing if it might just say minimum. So if it just says find the maximum and find the minimum, that means absolute. Okay. So we're going to find the absolute maximums and minimums on f on the closed interval and state where these occur. So what we need to do here are these 3 steps. We need to find the critical points, because that's where maximums and minimums could occur. And then also the endpoints, because the endpoint may not be in Extrema, but just like the picture we just showed before, that it could just be the highest point. All right, and then the least value is the minimum. So the value, by the way, is going to be the y's. That means the y value. Okay, so this doesn't specifically state what is the maximum value. It's just asking to find them. So these are just be points. So we're going to be listing out points. So first thing is find the critical points. So to find the critical points, I'm going to set f prime equal to 0. So what is f prime? Well, let's go ahead and go through this problem. We're going to get 3 times 2/3 x to the -1/3 minus 2. And we're going to set that equal to 0. Do a little bit of cleaning up here. We're going to get 2 x to the -1/3 minus 2 equals 0. Okay, so what we're going to do is set this equal to 0. So we need to solve for this x value. So I'm going to move that 2 over the other side. We divide by 2. We're going to get 1. If you're totally lost at what this is going to be the 1 over the cubed root of x. And then you're going to cross multiply. So really the cubed root of x is equal to 1. So right here, this is all algebra. And this is going to give me x equals 1. So I only have one extrema. So I have to test through a couple of things here. I have to test my endpoints, and I have to test my extrema. Now, I'm actually missing something. So right now, I only found the stationary point. It's from the previous page. Okay? Where is this also undefined, the derivative? Okay? And that's the part that people sometimes miss out on. So when I'm at this right here, let me rewrite this so it looks a little bit cleaner. This is actually 2 over cubed root of x minus 2. Okay? This is actually undefined at a point. So you can't plug in a 0 for the derivative, because the derivative then the derivative is undefined. So if you see anything on a fraction on the bottom, it can't equal 0. Okay, so in this case, I'm going to have x equals 0, and that's going to be my singular point. So this one has a stationary critical point. Usually people find those pretty easy, and this one's the singular one. So now, I thought I had 3, but actually I really have 4 things to test now. So I'm going to make a little chart. So my x and my f of x. So I'm going to test the endpoints, -1 and 8, and I'm going to test my critical points. Okay? Now, I'm plugging this back into the original. I want to see what the original is. Okay, so when I plug in a -1, I have a little cheat sheet next to me. When I plug in a -1, I'm going to get a 6. If I plug in an 8 is going to give me a -3. If I plug in a 0, I don't need the cheat sheet. That's just a 1. And if I plug in a 1, I'm going to get a 2. And this is all the work that you're going to need for this. So now let's go ahead and answer this. So do this in color. The abs max is going to be, well, the highest value is right here at 6. So it's going to be the points -1, 6, because it only asked for the point. So the abs max is -1, 6 is the point, and then the absolute min is going to be the point, well, 8, -3. So in this case, my endpoints were the ones that were super important there. Okay? So if it asks you for the value, the absolute maximum value is 6, and the absolute minimum value is -3. But if it asks you for the point, then you would give them that answer right there. Okay? Let's move on to the next one. So same first step here is we're going to take the derivative and then set it equal to 0. So what's going to happen here is we're going to get a bit of chain rule here. So we're going to get 2. So f prime is going to equal 2 sine of x cosine of x, because the derivative of sine is cosine, plus the derivative of cosine is actually going to make that into a negative sine of x. And that's going to equal 0. So we can find our critical points. Now, if I'm looking at this derivative, it's actually not undefined anywhere. So I don't need to worry about my singular points, just my stationary one. So set this equal to 0, and I'll be good to go. There is a GCF here, and that's going to make my life so much easier. I can pull out a sine of x. So I'm left with 2 cosine of x minus 1. And that's at, it's going to equal 0. Now, sine is going to equal 0 a bunch of times, but look where our interval is. Okay, so our interval is going to be from 0 to 2 pi. So I only care about when it's 0 in those. So when I set sine of x equal to 0, that's going to happen at 0, pi, and 2 pi. You got to be a little sharp on that trig there. You got to know that stuff. So these critical points actually do occur on my endpoints. They overlap, not a big deal. All right, it's actually going to be easier for me not to forget the endpoints then. And then when I set 2 cosine of x minus 1 equal to 0, I'm going to get cosine of x to equal 1/2. So when does cosine equal 1/2? All right, this is stuff that you do have to know. It's going to be at pi over 3 and 5 pi over 3. So those are the 2 points that's going to happen at. Okay, got to know that trick. So now, make my chart here. Because I know I have all my points. I already said that there's no singular points. It's not undefined anywhere. So I have my 5 critical points, my 2 endpoints, and they overlap here. So that's no big deal. So I'll list everything out now. So I have 0, pi, 2 pi, pi over 3, and 5 pi over 3. All right. And again, I'll plug this back into the original. So you plug in a 0. I did my little cheat sheet over here because it will get a little complicated in a second. So 1, not a big deal. The 0, the pi, and the 2 pi should not be too difficult. When I do plug in the pi, that's going to give me a -1 because there's going to be 0 and cosine of pi is -1. And 2 pi is actually going to produce the same value as the 0. So this is also going to be 1. When I plug in a pi over 3, this one's going to take a little bit of work. I'll do my side work right over here. So sine squared pi over 3 plus cosine of pi over 3. Well, sine squared of pi over 3 is going to be root 3 over 2, and that's going to get squared, plus cosine of pi over 3 is 1/2. So that's going to give me 3/4 plus 1/2, which is going to give me 5/4. All right, and then when you plug in 5 pi over 3, you're actually going to get the same thing. Reason is cosine squared, because that would usually produce a negative root 3 over 2, but that's not going to matter because it's getting squared, so you're actually going to have this right here. All right, so let's talk about what is my absolute max now. Actually, I'm going to have, it looks like I'm going to have 2 of them. All right, well, so I actually have one max value. So if I'm looking at this, I'm just going to answer this slightly different. So the value is 5/4, and this occurs at and 5 pi over 3, 5/4. Because sometimes they'll ask you for the x values. They'll say, where does the maximum occur? So if you were to ask where it occurs, these are your answers right here. What is the max? Your answer is right here, is 5/4. So that's important to know. This doesn't necessarily state it. Questions are going to be a little more clear. It's just notes, so that's why I'm just doing absolutely everything. And then the abs min, the value is -1, but that occurs at pi comma -1. All right. And that is everything you need to know about the candidates test.